well, maybe not my last, but it's definitely one of my last videos on GeoGebra using, and this is kind of cool. I'm going to use transformations, uh, and one of the things that I like to do with this is I had students the other day make um, a ride, but it had to have very specific uh, requirements. And one of the requirements was that it had a radius of 3 centimeters. That's not true. Diameter of 3 centimeters. So the first thing they had to do was they had to realize that that means a radius of 1.5. So I now have a radius of 1.5, which means my circle cannot be changed. I can change the position, but I can't change the size of the circle. And that was pretty good. The next thing I wanted them to do was this. I wanted them to have 8 arms that went around the circle. Now, I didn't care how long the arms were, so I told them, make a segment and have it go straight up to a point. And they did that. And I said, okay, well, if we have 360 degrees, I want them to have 8, I want 8 of them equally spaced. How could we do that? And lo and behold, somebody said, well, what if we took 360 and divided by 8? And sure enough, we did that. So I click on my segment, I click on the center of the circle, and I type in 45, which it already does. We do clockwise, and that happens. So you can see, this is kind of nice, because if I keep on clicking on it, it keeps on happening. So I don't actually have to do a whole lot of work. And the nice thing about this was, it ends up being, ended up doing it over and over again. And the part that students liked the most was, once we were done with this, I go back to move, I click on here, click on one of these, and then I click over here, and I went to here, and I changed the color. And you would not believe how excited the students actually were. Well, you probably would believe if you were a teacher. The nice thing was, after they got done doing this, and look, I can't even stop myself, so I guess really who am I to judge? The nice thing is, I told the students I didn't know how big the arms of the ride were. I did tell them that the ride sat, and by the way, if you want more colors, there's more there. I did tell them that the ride sat 10 feet off the ground, and so, and it was, the reason why the diameter was 30 was because it was, what? It was, the circle, the center, the circle here had a diameter of 30 feet. But then I also told them that it went up 150 feet, so we were dividing everything by 10. So you can see now, 10 feet off the ground, my center is there, and now I need to get up to 15. Well, here's the cool thing about this. If I drag this up to 15, all the spokes change because they were all together. Now, you might say, well, that's great, except now your bottom is no longer 10 feet off the ground. That's not a problem. I'm going to grab my circle, and I'm going to move it up and up until I get to there. So now you can see I'm at 15. It's 10 feet off the ground. I'm going to shrink my screen a little bit. And I told the students that this, I'm going to go to pen, is 150 feet. It was 150 feet off the ground. And I wonder if I can actually just do this a little bit easier. Oh boy. Well, that's no good now, is it? So let's see. Let's see if I can do this. Oops. I'm going to... Oh yes. If you just click on it and press delete, it deletes. So I'm going to try this one more time. I'm going to take my pen. The whole thing was 150 feet. This was 10 feet. This was 30 feet, and this is much easier to do on a smartboard, obviously. That's 30 feet. So this ended up being x, and this ended up being x, and the students were able to write an equation. X plus 30 plus x plus 10, and I know this is coming out terrible, equals 150. And the nice thing about this was they were able to solve the equation, and they understood what the x's actually stood for. And I always thought that that was very, very, very useful. Probably the most useful part of the project was having them understand what on earth they actually were doing. Now, that's not the only thing you can do. If I wanted, I could highlight, go to move, and I can try to highlight. It's not working for me. If I press Control, I can highlight all the objects. Of course, if you miss one, then you're kind of up the creek. What if I did this? Nah, alright. Well, this is not working well for me. I don't know why. It usually does. Alright. Well, what I'm trying to do is I'm trying to just collect everything all at once, and it's not letting me do that. And I don't know why. That's fine. Oh, here we go. If I go to here and I click on algebra, all these things come up. And if I click on them all here, it's a little bit easier. What I can then do is I can go back to here and say reflect about a line. And so I selected my objects, and then I can pick my line, and hopefully it will reflect it, and it's not going to, which is not nice. So you can see sometimes Geogebra, even for the best of us who have used it forever and ever and ever, can always still be a little bit temperamental, famously. And everything's falling apart. It's funny, as I try to explain this, it becomes harder and harder for me to actually do it. Uh-oh. As is evidenced by that. Alright, so let's see. I'm going to try this one more time. Well, I reflect about a line. And I guess I could do it by pieces, but that's a little annoying. You just select the object and then the line you want to reflect over. And the nice thing is, it always does give you the values of everything, so it's not really that big of a deal. If you're not careful and you miss, like I've just done a couple times, you will run into problems. And ideally, yeah, I think I've run into problems. And the nice thing is, the kids will run into problems too, but the kids are, it's a computer, so they'll be more likely to keep at it. Yeah, you can see I missed a couple, so. Just keep at it, and you get the same thing. Miss. Go. And there we go. Oh, and anyway, you get the point. the nice thing is you can also do translations, you can rotate around a point, you can dilate, and lots of other things. What I'm going to do is, I'm going to actually, I don't want to say this. I want to show one more thing. If I have a circle, and I want to find the area of the circle, go to here, find the area of that circle, and then if I want, I can do another circle on the inside, and if I find the area of that circle, you can do this. And so the reason why this is neat is because, once again, if you use the text box, you can get these or the checkbox, you can get the areas that go away. But one of my favorite questions of all time is, if I have one circle with a radius of 4, and I have another circle with a radius of 2, and I cut out the inside circle, is the area of the outside circle going to be twice the radius of the inside circle? And the reason why I like this problem so much is because when you do the work, you'll find out that the answer is no. But if you do the actual, if you leave your work in terms of simplest radical form, you'll realize that there is some kind of pattern going on. In any event, I think I've gone on way too long about this. I hope this helps. Alright, thanks. Bye.